Everybody, this is AI with Dr. Craig Hansen, and I'm delighted to be here with Alex. Good morning.
Good morning, Greg.
Hey, great article about AI and risk management. Thanks for doing that on LinkedIn.
Well, thank you very much.
Why don't you tell us about your background and where you come from and how it's led up to this point in time with AI?
Sure. So, since a young age, I was fascinated by computers. So I started coding when I was 6 or 7 years old. Good old BASIC on a Commodore 64. Many of your listeners probably don't even know what that is anymore. But yeah, I was in IT all my life, my professional life. I worked for Cisco. I spent a lot of time in network engineering. Did software development. Worked for Deutsche Telekom, and then for Verizon. Where recently I ran the cybersecurity product organization. So I was always in IT, started as a coder, as a developer, did probably 10 years of network engineering, and then moved into the space of cybersecurity. And really a year and a half ago, got more and more interested in AI and machine learning. Cybersecurity is increasingly, or has been increasingly, using AI for the purpose of providing more powerful and capable cybersecurity capabilities. But now, as everybody has seen with the explosion of large language models, we see kind of a second spring for AI and machine learning, meaning many of the machine learning models and technologies out there have been around for a long time, but they have kind of gotten an increased interest because large language models are much more tangible and comprehensive to the average user, meaning it's easier to imagine what the future might look like leveraging AI with large language models because it's less abstract and it's more tangible.
Right.
So
And
to finish the introduction, so that led us to found a startup, because the more we were going into AI and machine learning, the more we realized that in particular, modern methodologies, such as called deep learning, are very, very, we call them black boxes, meaning, you send data into the model, you get a respective output, but it's not clear to the user how the machine has made these decisions and how the machine has come to a specific prediction. And that ultimately led us to, address that problem. And we have founded, to your reference to the paper, an AI risk management and explainability company.
right, that was going to be my question. Tell us about how that led to this. And is that part of AI 2030? I saw that you're involved in that organization as well.
It is not. I have joined AI 2030 as an advisor, and it's very positive to see how much activity there is in the industry around responsible AI, ethical AI, safe AI, because while our imagination, was spurred on by all these capabilities that we've seen with large language model, there is also, an increasing awareness of the potential risks that come with these models. And we can obviously talk about this in more detail later. But AI 2030 is the fastest growing advisory group at the moment, and it's a cross-industry, cross-functional group of members who look at different aspects of AI, from the very technical part, like we are doing, to more philosophical questions around ethics, for example.
How would principals or educators and institutions or schools engage with AI 2030, and what sort of benefits would they gain?
I think AI 2030 is in its current stage mostly about hearing as many as diverse voices as possible, right? AI touches literally every industry and it manifests differently in each industry, both the benefits and the risks. And I think AI 2030 would benefit a lot to hear the perspective and the insights from a perspective of an educator, because in education particular, I mean, I see it with my older son who is using ChatGPT on a regular basis, but we had a long conversation about how to responsibly use ChatGPT so it becomes a tool that adds to his toolbox, if you like, without any of the of the inadvertent effects it can have.
Right. And so the how do I pronounce it? A iceberg?
Yeah, we just say iceberg, but yes, a iceberg.
Iceberg. And as I was reading through the article, which is really thorough, discriminative versus generative AI, can you define
Mhm.
that for us?
So discriminative AI or non-generative AI, or some people call it classical AI, has been around for quite some time, probably 15 years, if not longer. And it's really about training a model to make generalized decisions based on a finite set of data. Now, that sounds very complicated, and it's not. It is basically you provide so-called training data to a model that has examples. It has examples that say, if we find the following variables with these values, it should be class A. So let's take an example. You apply for a mortgage at the bank, and the bank runs your data through a machine learning model. And the two classes that the model has is Greg should get the mortgage or he shouldn't get the mortgage. So based on that training data, we teach the model to make general decisions based on what it has learned from the training data. Now, the training data is a subset of reality, is a subset of what we call the world. But good models will be able to make decisions beyond the boundaries of this training data. Excuse me. Meaning, if this model goes into production and is used, in our example at the bank, it will perform well by making generalized decisions about based on certain inputs, which normally would be, in our example, income and, credit history and things like that. It will basically classify into either, one class or the other, in our example, should be granted a mortgage or shouldn't be granted a mortgage. Now, there are so-called regression models that don't look for a class, should it be A or B or blue or green, but that look for target value. And both models are predictive models. They predict an outcome, but the outcome differs between being a discrete value across a certain range or whether being a class. And classification is the most common and used task, if you like, in machine learning. And it can range from, financial applications such as mortgage, all the way up to drug development, pharma, predictive maintenance. So, the list goes on and on. So these are the classical AI. And you will find large enterprises having hundreds of these kinds of models. They're very specialized, and they often work together, right? Often you have one model having a variable, an input, that is actually the output of another model. Now, generative models, they work very differently. Generative models technically are highly specialized deep learning, so-called deep learning models. And what they do in lightning speed is make predictions about a sentence and what each word should be following, a particular word. So they will, to some degree, understand the context, and based on the question you ask, they will, give, in most cases, an accurate answer. Because it happens so fast in real time, it creates the illusion of, that the model is sentient or has some degree of intelligence, which it absolutely does not. It's just, in insanely large and fast computation that creates the illusion of basically, the presence of some degree of intelligence. But as I said, what it basically does, it's basically a predictor on steroids by being trained, and then based on your prompt, on your question, making a prediction word by word in sense of the respective answer.
Right. And the generative AI, does it need to have an open access to multiple databases or online information, or can it work with a closed knowledge base?
When it's originally trained. So ChatGPT 3, I believe, took a full year to train, and it took 32,000 graphical processing units. So we're talking millions and millions of dollars just to train ChatGPT 3. Of course, the model is updated both from a content perspective as well as a capability perspective. So I think we're on version 4 now. But but after it is trained, it is fully operational. Now, ChatGPT 3 captured the internet from a content perspective up to the year 2021, I believe. So to your point, it is necessary to update these models on a regular basis as we move through time, and obviously new content becomes available.
Right. Okay. Also, on your article, you mentioned a list of concerns or a list of things to
Mhm,
be aware of, and I noticed one of them was fit for purpose. Can you talk more
mhm.
about that?
Yeah, fit for purpose mostly refers to what we call model elasticity. And without getting too technical, let's go back to my previous brief explanation about using training data to train a model. So you might have use cases where data stays very static, which means it doesn't change. So you put your model into production and real data is being fed into the model, but the nature of the data doesn't change. So there is no change, no fluctuations. So the model will perform reasonably well. But there are use cases where the world is changing, right? So I'll give you extreme examples: the stock market, the weather, certain
Mm,
demographic developments that might change over weeks. So it is very important for AI operators to continuously monitor their machine learning models to determine whether they're still fit for purpose. So fit for purpose in the sense of, is my model still fit for the use case that I have designed it for? Because the world might be changing, the data that is processed by the model does not
mm,
really resemble the training data anymore. And this
right.
means the model will deteriorate pretty fast and produce inadvertent outcomes.
Right. So for educators, principals, leaders of institutions, what are some concerns and some opportunities that you see with AI for education?
I think on the opportunity side, I think it's a massively powerful tool. Um, because the way I think or believe education is changing, and I just observing my children, is it is not only about learning things by heart anymore. When I went to school, learning things by heart was basically the number one objective, and be able to reproduce these things. I think nowadays it's more about giving children the right toolkit, the right skills, which is logical thinking, rational thinking, reasoning, because they have access to any piece of information, imaginable. And what LLMs, large language models, do, they basically provide kids with a search engine on steroids. So when my son studies for math or
Right.
chemistry, in the past he would have to be very specific in Google about, Googling certain things and then taking this information, piece by piece and deriving the respective answer for himself. Now he can ask the specific question to a large language model and
Mm,
get the answer. Now, the danger there is obviously in, children or students basically misusing large language models to basically create content. So I was
right.
referring earlier to the conversation I had with my son, where we were very clear about when it is okay to use a large language model to supplement research, to supplement, specific questions. But the original thought and work still has to be done by him. What I don't want to see as a parent, and I guess educators, is that students start misusing the large language model to create entire bodies of work, to create content that is not their original content. And luckily, there is more and more tools out there that help educators determine in an automated fashion to which degree a large language model was potentially used.
Mm. And so looking forward, going forward, for schools that may not be yet having policies in place around procedures of teacher use and student use, who may not be using it within the curriculum for students to learn, what do you think are one or two things that schools could do to dip their toe in the water, as it were, with AI?
I think first of all, it's about awareness. So it's very similar to the advent of cybersecurity, right? When cybersecurity became a real serious issue and requirement obligations, there was a lot of work done around awareness. I think it starts with awareness that people are comfortable with the core principles of the technology, the advantages and disadvantages, and the educator's expectation. It doesn't matter whether they can police it already or not with respective tooling, but simply by making the students aware what are the boundaries of using automated tools such as ZGTP, I think is a very first important step. And then, as I mentioned before, I think eventually schools need to prepare themselves with the respective tooling to have some detection capabilities.
Right. Very good. Well, look, Alex, I really want to thank you for your time and appreciate the work that you're doing. And
Well, thank
if
you.
people wish to reach out to you, what's the best way to do that?
Oh, it's very easy. It's info@iceberg.ai. So info at iceberg AI and then the iceberg.ai. And yeah, we are more than happy to answer questions, step into a dialogue, whatever the topic is.
Wonderful. Thank you very much for your time.
Well, thank you, Craig.